Hey everyone, so in this video I want to talk about server-sent events and how we can scale them using Redis and a bunch of other technologies. So in a recent project I was working on, we had to implement a real-time notification service in a NestJS application. We use server-sent events to implement that service. We could have also used WebSockets, but server-sent events are much more simple to set up and configure as compared to WebSockets. And WebSockets are more suitable for use cases where bidirectional communication is needed, such as chat applications. So after we had implemented the service, we deployed it to production, but in production it did not work as expected. In fact, it did not work at all. So what was different in our production environment? The first thing was we were using pm2 to run our Node.js application in cluster mode. What cluster mode does is it runs our application on multiple cores that are available on our machine. It creates multiple instances of our application, and the incoming HTTP requests are automatically load balanced to each instance. The second thing was we were using our application was behind a reverse proxy, nginx in our case. This was being used to enable SSL and some other stuff. We can also use nginx as a load balancer, but pm2 automatically does this for us. So these two things, pm2 and nginx, introduced two problems for us. Number one was that if you look at the docs for the cluster mode, it states that our application must be completely stateless. So stateful services that rely on a persistent connection between the client and server, such as WebSockets, and in our case, server-sent events, they don't work as expected. And the second problem was that this reverse proxy was killing our SSE connection after 1 minute intervals. So next we are going to uh, look at these problems, and we will try to fix these problems. So I have created a demo application using NestJS and Docker. We are using Docker to run nginx and Redis. We will be using Redis to scale our SSE service. So the first thing I want to show you, first let me check which branch I am in. Let me switch my branch. In this branch, this demo application is available on my GitHub, and in this branch, I have replicated all the problems. This is our NestJS application. There are just two main files we need to look at. The first one will be our controller. As you can see, we have three main roots here. The first one is just a hello world root, which also returns our process ID. This will be helpful when we are debugging in cluster mode. And the second one is our web client can use this root to establish an SSE connection. And in this one, we return an observable, which will keep returning all the events to the SSE connection. We are subscribing to the main channel of our SSE service. Here I will open our SSE service file too. Here in our SSE service, we have created an event emitter, which will use the from event method from RxJS to return an observable, and it will create a channel using the channel name we have provided. The second method is emit, which will basically push a data object to the channel we have specified. We'll use that emitter object to push the data to the specified channel. And here in the third route, where web client can make an HTTP request to this endpoint, and it will use our SSE service to emit an event. In this case, we are passing this object as the data that will be received here and will be emitted on our event emitter. And then it will be returned from the observable we had earlier returned when the SSE connection was established. Now let me just run this application and show it to you. We'll run this as a normal application without pm2. And it is running on port 3000 as all NestJS applications do by default. Here you can see it returned our process ID on the hello world root. Now I will run my web client. I have created a simple web client too. What this web client does is it simply uses the event source API to open an SSE connection. And right now we are running only on port 3000. And I will run this using Python's built-in HTTP server. Here in the network tab, you can see we have established an SSE connection, and whenever I push this button, it will make a call to the fire event. Here we will make a request to the fire event endpoint, and this will push this object to the event emitter, which will be returned from our SSE connection. Here you can see we got the same process ID, and we are making multiple requests to the fire event endpoint. And this data is getting returned from the SSE connection. And now I will stop my NestJS server and run it in cluster mode using pm2. And here I can specify how many available cores I want to use. I will use 4. And as you can see, I'm now running 4 instances of my NestJS application. And here you can see every time I'm getting a different process ID. So what is happening here is, let's say these are my instances of my application, and every time the pm2 I have scaled there, here is the pm2 load balancer. And whenever one of my clients sends a request, it will forward it to a different instance of my application. And similar will be the case for SSE connection too when we try to establish it. In some cases, the SSE connection may be, for example, for this client, the SSE connection may get open to this server, to this pm2 load balancer, and sometime to this server, and sometime to this server. Now when I will send these events, these fire event endpoints, you can see I'm not getting anything in return. even though I'm still running on the same localhost 3000 port. So this is what the pm2 docs meant by that our stateful services won't be working correctly in cluster mode. So how we are going to fix this is we will introduce a Redis layer here. We will introduce Redis, and to be more specific, we will be using Redis pub sub feature. Redis pub sub. We will be using Redis pub sub feature to push our events to all of our applications will basically subscribe to a Redis channel, and whenever we have to let's say this client performs some action, it calls the fire event endpoint, which is supposed to notify all of the connected clients, and this is connected to this server, and whenever this calls the fire event endpoint, our application instance will publish an event to the Redis server, and our Redis server will notify all of our application instances. Then our application instances will know that there is an event which they need to notify every SSE client about. Okay, so far so good. So now I want to show you the second problem, which is when we put our application behind a nginx reverse proxy, the proxy kills our SSE connection if it is inactive for too long. So first, let me show you my Docker file. Here I have a service for nginx. I'm mapping its internal port 80 to our external port 8080. And next I have a nginx configuration file. In this file, I have basically configured my NestJS application running on port 3000 to be put behind the nginx reverse proxy. So the nginx will be listening on port 80, which we have mapped to port 8080, and we will be able to access port 8080 in our browser here. So right now you can see our SSE connection is established. You can check in the status, there was nothing, so it means it is still open. This error message is for the older ones. Here you can see the status, it is blanked. If it says closed, then it means it is disconnected. And right now, even if you wait for long, this connection won't get closed. Here you can see this line proxy read timeout. It is set to 60 seconds, which is its default value. So this is what causes the nginx to kill our SSE connection after a minute or so. Let me just, in my web client, let me change my port to 8080, and I should now check if my Docker service is running. My Docker daemon. It is inactive. Let me just start it. Okay, so it is running now. Okay, now I want to start my nginx server using Docker. Okay, a little bit of typo there. Okay, so our nginx server is running. Now let's directly access our nginx server, our web application using port 8080. As you can see, we are getting reply from our NestJS application, which is now behind the nginx. Okay, so our SSE connection is established on port 8080. And let us now try to send some events. I am clicking on it, but I am... Okay, so we should wait 1 minute here to see if it gets killed or not. Meanwhile, let me just switch my branch to master. In master branch, I have fixed all of these two issues. So we just need to wait a little longer here, and the nginx should kill our SSE connection. Okay, the nginx killed our SSE connection, and you can see in the status, it is now closed. So one potential fix for this is that we can set this timeout number to a very large number, but that won't be an ideal solution for this problem, because if some other HTTP requests to our server are taking too long to be responded, they won't get killed by our nginx server. So it is better if we just leave it at the default value. There is a better solution for this, which we will soon see. Okay, so now I'm in my master branch, and here in the controller there are no changes. The main changes are in the SSE service file. So let's just focus on this. So here I have two Redis clients, one for publishing and one for subscribing. We cannot both publish and subscribe on the same client, so that's why we have two different. And in my constructor, I'm just initializing these clients. And next you can see I have created an interval which gets called after 30 seconds. And in it, I'm just emitting a dummy event of type ping. You can pass anything here you want. I'm just using this type ping. And what this will do is it will help keep our SSE connection alive and not get killed by the nginx server's proxy. Next, I have subscribe method, which just subscribes to the provided channel using the Redis subscriber and returns an observable, which returns an event whenever our Redis subscriber receives a message. And how it will receive this message is in our next method emit, we are using the Redis publisher to publish a message on the provided channel. And in the controller, you can see everything is the same as before. No change needed here. Okay, let's see if our solution works. SSE connection is established. And let's try sending some events. We received one event, but we should receive all of them. Okay, so I think I have not, I need to restart my pm2 clusters and update my NestJS code because I switched my branch to master, which has the solutions, but I have not compiled my NestJS application yet. I need to recompile it. Okay, it should build with the latest code now, and let me stop my Docker containers because now in the master branch I have the Redis server 2 in my Docker. Here you can see we are running on port 55,000, our Redis server. Now we will run both our nginx server and Redis server. Okay, so both are running. Now let us restart our pm2 clusters using the latest NestJS app code. Okay, all four of our clusters are up, and we are now receiving all of our events successfully. And here you can see all of our process IDs are different, which means whenever we uh, make a request to the fire event endpoint, it goes to a different instance of our app, and we get a reply on the SSE connection from that app, from that instance. And you can also see the ping messages, which there are four because there are four instances of our application. And these will keep getting sent after every 30 seconds. And because of this, even if we wait longer, even if we don't send any event on the SSE connection, and we keep the connection connection inactive for longer than a minute or even 10 minutes, it will be kept alive for as long as the client and server do not disconnect. Okay, so I think that's all for now. I hope you enjoyed it and learned something, and I hope it will be helpful to you. Thank you.